So it's a long title. I'm going to be concentrating more on science, I think, than theology. But models are used quite extensively in both science and theology. And what I want to do is look at some of the common structures in science and theology and the connections between models and presuppositions and worldviews. So if we look at the definition of models, there's various definitions. If you read Barber's book on myths, models, paradigms, that I'm referring primarily to what he calls theoretical models. A theoretical model is a framework of ideas and concepts that we use to interpret our observations and experimental results. So it can be a simplified representation, if you like, or analogy of some aspect of physical reality. And in science, this often makes use of mathematical equations. That's what makes the models very powerful. So in science, we could distinguish between observational data on the one hand, inferences, correlations, regularities made from the data on the other hand, and thirdly, theoretical models that try to explain and extend the first two. So, for example, we might have observational planetary positions. From that, we can infer Kepler's laws. And then as a model, we might have Newtonian mechanics that explains these laws and extends them. Now, theology, you can have similar sorts of situations. There, too, one often makes use of models. So Cortez, for example, in talking about theological models, says it's a simplified representation, metaphor, or analogy of some aspect of reality that explicates, clarifies, or extends theological concepts. Its prime purpose is to suggest potentially fruitful lines of inquiry and to make new discoveries. It's very similar to scientific models. In theology, we can distinguish the first level, religious experiences, biblical assertions, second level inferences from those, and thirdly, theoretical models that explain and extend. So one example might be human sinfulness. At the first level, we might extend that or infer total depravity from that. And then we might have something like the penal substitution model of the atonement, for example, to explain that and to put it in its context. Now, models can be used for a number of different things. So, for example, on the one hand, we might have a simplified qualitative representation of reality, reflecting philosophical and theological truths. A second usage may be to save the appearances, dealing primarily with quantitative accuracy for prediction, for example. So, for example, here's Plato's cosmological model. Note the four elements in the center and the rest of the universe around it. Or one might look at, so here we have a simplified representation of reality. Note the five elements. The circular motion reflects eternal perfection, and so on. Or if you look at Dante's cosmology, here we find that we have a model that interprets various theological beliefs as well. So note here that we have the earth, as with Plato, but right in the center of it we have hell. You'll note that there are 7 levels. Gluttons, you may be interested to know, are on the fourth level. But here we have basically something that's concerned with reflecting a theological belief, if you like. Now, models are very successful, particularly in science, and particularly because of the mathematical aspects. It was noted by previous speakers, for example, the uncanny ability that somehow mathematicians arrive with mathematical theories and concepts that anticipate their need in physics. So Steven Weinberg, in his book, The First 3 Minutes, which was mentioned earlier, writes that this ability of mathematicians to anticipate the math needed in the theories of physics is quite uncanny. It's as if Neil Armstrong, when he first set foot on the moon, had found the footprints of Jules Verne. And in a more recent work by Mark Steiner, he notes the fact that the universe seems to be very user-friendly to human mathematics, that it's even the notation of mathematics that lends itself to further discoveries, particularly in physics. So here we have examples, quantum mechanics, general relativity, of mathematical models that have been tremendously successful in science. On the other hand, we have to be careful not to be too carried away with that, because there are a few dangers. One is that in these models we do have a certain amount of abstraction. So often abstract mathematical concepts introduced during the development of a mathematical model are passed on as physical concepts, making reality seem weirder than it actually need be. So for example, electric fields, here we have action at a distance, something Newton tough time explaining, but is this a physical thing or is it just a mathematical abstraction, the concept of a field? Or the quantum mechanic wave function, are these real? Do they represent reality, or do they just represent our knowledge of reality? Or Stephen Hawking's makes use of imaginary time. Is this really a fourth dimension or fifth dimension, maybe, imaginary time? Or is it just a mathematical abstraction that doesn't really have any direct physical significance? Another danger we have is the fallacy of misplaced concreteness, as Keith Ward calls it. The fallacy of misplaced concreteness is that we mistake the abstract model for the concrete reality. And I guess this is most prominent in the reductionism that we find in materialism. So for example, Sir Francis Crick writes in his book, The Astonishing Hypothesis, the astonishing hypothesis is that you, your joys, your sorrows, your memories, your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells, which seems to suggest that all of your thoughts and beliefs are illusions. And if that is the case, what does that make of this particular belief that Crick has, that all your beliefs are illusions? It seems to be self-refuting at some level. So here, the danger is that one's actual concrete experiences upon which the model is ultimately based are relegated to the realm of mere subjective illusion, and the abstract model becomes the true reality. You find the same sort of thing in Penrose, for example, where he has the three worlds, the worlds of mathematics, material world, your mental world. And he concludes that the real world is the world of mathematics, that the other two are just thin shadows of it, illusions. So here we must be careful that we remember the proper limits of mathematical models. Models of the universe function like maps. A map is just an abstract representation of the landscape, and as such should never be mistaken for the real thing. Another problem with models is that we can have more than one model that represents the same phenomenon. Here we have the model of Copernicus. When Copernicus' model came into being, the question was raised, is this now a real model of reality? Or is it just a useful fiction that we can use to make predictions, but does not correspond to the actual reality? I think Copernicus took the second point of view, but Osiander in his introduction took the first point of view to make this model more compatible, if you like, with current day thought. The problem is that you could come up with a model, a Tycho Brahe's model, which observationally is equivalent to the Copernican model. And since they're observational equivalent, how can you choose between the two? Okay, which is the true model? You have the same sort of thing in astronomy. If you look to the light coming from galaxies, you'll find these are redshifted. The further away, the greater is the redshift. How do you explain that? Well, it could be caused by expanding space. That's the most prominent explanation, but there's lots of other models. It could be motion through space, Doppler shift, gravity. This is a model by George Ellis. Speed of light could be decreasing. You could have shrinking atoms instead of an expanding universe. Same observational effects. or the mass of particles could increase, or maybe light just gets tired as it moves through space. This is an old theory that goes back to the 1920s, and it predicted that as it loses energy, it warms up the interstellar space. So they predicted a 3-degree background radiation, which was actually confirmed, right? So that last one, we may laugh, but it has a few things going for it. So the question with models is how do you choose which model is going to be? And it seems that a mathematical model somehow bridges the gap between one's conception of reality and appearances, thus strengthening the case for that conception of reality. So for example, Copernicus was not widely accepted until his model was tied to a physical model, which was after about 1650, after the physical work of Descartes and Newton. So relativity, however, gives Copernicus and Newton Newtonian models, or Tychonian models, equally physical supports. So how do we choose between Copernicus and Tycho? That raises the question, what does absolute motion mean? How would you define it? So there's a famous Duhem-Quine thesis that says that we can construct a model with any given feature if we make drastic enough changes elsewhere in the model. So if you want to believe in a flat Earth, it's possible to make a model that will fit that, but there's a price that you have to pay. So how do we choose a model? Which models should we prefer, given that we can explain the data with a number of different models? Should it be the simplest? That raises the question, how do we know that simple models are more likely to be true? We have no certain means of separating true models from false ones, so we choose models that fit in best with our worldview, our most basic assumptions about how we think the world is like. So from data to theory requires an epistemic jump. So I would argue we start with data, we derive theories, but the theories also have input from the imagination and also from our worldview, that we reject theories that contradict our worldview. And the theories, if you like, bridge the gap between the data and the worldview. Is science worldview neutral? It's largely thought that it is. Although Mahner and Bung, in an article in 1996, suggest that science must presuppose materialism. They argue that without materialism you can't have any science. Fishman, on the other hand, argues that science itself is worldview neutral, and that naturalism is not a presupposition, but rather a tentative conclusion of science. Both of them, though, see strong connections between science and naturalism. Let me look at some of the presuppositions that we need for rationality and for science. If you're going to have rational discourse with someone, that presumes that there is a purposeful knower, yourself, that we have reliable senses and a reliable mind, that there is such a thing as objective truth, absolute rational values and logic, that there is an objective language, how else can you communicate ideas, and that there is such a thing as mental causation, that our minds are just not a reflection of material things, but that ideas can cause physical consequences. And if you want to do science, that presumes, in addition to these, that we have an orderly and comprehensive objective universe, the uniformity of nature. The laws that we see here and now are the same everywhere, always. And the applicability of mathematics, that there is such a thing as mathematical truths. Physics is largely mathematical, so if you believe physical theories are true, then you must believe that the mathematics behind those theories is true as well, which causes a problem for materialism, because where do you put the mathematics, which is an abstract sort of thing? Now we need various values to do science. So if we look at a viable worldview, this worldview should be able to account for the presuppositions needed for science. After I was working on this paper, I started to read some more stuff by Professor Artigas, and I find that he makes some of the same points that I do about the need for presuppositions for science, so that he finds that theism does this very well. It accounts for the presuppositions, whereas atheism and agnosticism leave them largely unexplained. In fact, as that quote from CRYF shows, the rational defense of materialism and postmodernity is self-refuting in that it explicitly denies the presuppositions that are implicit in its defense. If you're going to defend something, you're assuming there's other minds there, that they're going to listen to your argument, that there are rational, objective values, whereas materialism would deny all of these. Now, that raises the question, how should science and theology interact? Should theology, for example, influence the content of science, or are these two largely non-overlapping? Michael Steinmark writes that science as a whole is not worldview neutral, so he thinks theism gives a better explanation for the presuppositions needed. But he argues that theory should not be accepted or rejected on the basis of ideology or religion. Now, it must be noted here that models in science are certainly incomplete. They tell us nothing about ethics, aesthetics, meaning, or purpose. And models in theology primarily concern our understanding of relation to God. So I believe to a large extent science and theology are independent, or parallel if you like. They offer complementary descriptions of reality, but I don't think you can carry that out completely, because there are going to be differences in causality and epistemology in particular. Scientific causality is incomplete, first of all, because it doesn't take into account human causality. For example, physics cannot predict when human choices detonate a nuclear bomb. And this becomes even more so if we allow for divine intervention, then theism allows for the possibility of supernatural miracles. So empiricism, as far as epistemology is concerned, is incomplete. Theism allows also for the possibility of divine revelation. So I would argue that if theism provides a better account for presuppositions of science, we should also seriously consider that maybe theism also gives a better account for metaphysics, causality, and epistemology. And if we allow for biblical revelation, for example, then we have to allow for the fact that there may be a conflict between science and theology, or an overlap. Quite often this conflict is seen in origins. I want to talk instead about eschatology. I think that's more important. We've touched upon that a bit already in some of the previous speakers. Wolfhard Pannenberg he questions whether the biblical assertion of a future resurrection can be reconciled with Big Bang cosmology. So he sees a conflict here. Hans Kung, because of that conflict, Hans Kung argues that biblical eschatology is only metaphoric imagery that does not contradict Big Bang cosmology. Now, if that is true, I wonder what that means. Does it mean that there's no afterlife? But isn't that the central theme of Christianity, that we look forward to an afterlife? And if you're going to develop a theodicy, because of the pain and suffering we have in this world, you think that you need a future world to even things out, as it were. So John Polkinghorne and Bob Russell, we mentioned him, the previous speaker as well, they argue, on the other hand, that in this case, biblical eschatology should trump Big Bang cosmology. So Russell, in his project on theodicy, he ties eschatology into it quite strongly. So he would argue that, in this case, Big Bang cosmology has to give way, that it's not a conflict with science, but with philosophy, he would say, with the idea of uniformity of nature. And Russell then argues that ultimately science is just descriptive of what has happened, but not prescriptive of what has to happen in the future. So he would say that because God is in control, God can bring a discontinuity in the laws of nature in the future and bring in the biblical eschatology. Now that raises the question, naturalism. Do we need naturalism in science? And should we distinguish between methodological and metaphysical naturalism? So methodological naturalism is the notion that science is limited to natural causes, that scientific inferences are valid only to the extent that there have in fact been no supernatural events. So it doesn't rule out the possibility of supernatural intervention, as it were. Whereas metaphysical naturalism is the further assumption that there are, in fact, no supernatural events. The difficulty is that if you have mythological naturalism plus the assertion that scientific inferences into the future, for example, are true, then in effect you have metaphysical naturalism. So the final question I want to raise is, should science be Duhemian or Augustinian? A distinction raised by Alvin Plantinga. Duhemian science should be metaphysically neutral so that it contradicts no worldview. Hence, it should not incorporate metaphysical naturalism, which means that you could take the results of mainstream science to a large extent if you have an instrumentalist view of science, which I think Duhem actually had to some extent. But this is the science that we can all do together, because the differences in worldview are not going to affect the conclusions, the inferences that we draw, the models that we make. On the other hand, Augustinian science would incorporate explicit theological presuppositions about ontology, epistemology, and causality. So it may end up with different scientific models. It may end up with different conclusions about eschatology, for example, or also other things. I think my time is pretty well up, so let me conclude here. The main points I want to make here is that models are very useful in representing aspects of reality that are hard to visualize. They serve as conceptual frameworks. They can lead to important discoveries. They're closely related to worldview presuppositions. They link our worldviews with our experiences. That the presuppositions needed for science and theology are best accounted for by theism, not naturalism. Fourth, that for Christians, eschatology at least provides a decisive point of contact between science and theology, a point that we don't want to compromise on. And fifthly, that metaphysical naturalism is unwarranted for Duhemian science, and that the search for science as truth rather than technology will entail Augustinian science. Thank you.
Thank you. We're not, in fact, as tight on time as because we've moved. There's a paper being moved this afternoon, so we do have some time for some questions and observations. So, right, Professor Roger Trigg. We're just using this to record it, so I can.
Right. Could I just pick up on your fourth point there, that for Christians eschatology provides a decisive point of contact, which I think, I agree with you about the importance theologically of eschatology, but it seems to me that when you get people like Pannenberg saying that the cosmological future of the universe has something to do with resurrection, there's a very materialistic view of resurrection going on there, that actually there is no non-physical way of conceiving of the afterlife. Now, I do wonder, people may talk about the physical resurrection of Christ and so on, but it does seem to me that if you have a notion of the transcendent reality of God and really believe that God is not a physical object, and I certainly don't believe God is physical, then being in the presence of God, which is perhaps what the afterlife partly involves, surely involves a non-material view of reality.
Well, it's an interesting question. Of course, if you look at the Apostles' Creed, right, which is basic to Christianity, that does talk specifically about bodily resurrection. You know? Well, I believe life after life.
You could say it's the resurrection of the individual personality. You could interpret that it's not sarx, it's not flesh.
Well, Christianity, though, has always held that the resurrection is not just the soul, but also the body. You know, that the soul and the body are rejoined, as it were.
Yeah. You see, Aquinas got himself in a terrible mess over this because he worried about cannibalism and things like that, and whose body would it be in. And I think once if you get to that very materialist kind of way of thinking, I feel that mistakes are being made. Your view of eschatology could look a bit like kind of the Mormon view of an afterlife, of everybody happy in a gloriously material world, and that's not my idea of a Christian afterlife.
Do you believe in a subjective afterlife, I wonder, or? No,
I believe absolutely in the objective reality of God and the afterlife. Yeah. I absolutely affirm the reality of the creature. If Christ is not vain, if Christ is not raised, our faith is vain. I go along with that absolutely. Yeah. But it's just, do we have this very narrow physical view of what it is to be real? I mean, Christ's own resurrection is more than the physical.
I agree with you, but that would raise the question, is reality just the three dimensions that we see, or is there a wider reality, Carl High maybe, that there's more dimensions?
Well, that's what I'm saying, and also therefore a kind of transformed, transfigured reality is greater than just the physical reality. In other words, the culmination of the universe will take us to something greater, not just more of the same.
Yeah, I don't disagree with that. I would disagree with, for example, Tipler's point of view, where he tries to combine Big Bang cosmology with Christianity by saying that the universe will ultimately contract again, and that the whole universe becomes a big computer, which becomes the mind of God, and that we're resurrected only in the sense that this mind will have all possible thoughts, which includes the thought of us.
No, well, I'm absolutely against that.
Yeah.
Yeah. I mean, it's just what reality is, and I just think reality is more than the physical.
Yes. Well, I fully agree with you there.
I think it's probably a disagreement about how we characterize it, really.
Yes, but what I'm saying is that theology does have a bearing also on physical reality, because Christian eschatology, I don't think, I agree with Pannenberg that it can't be reconciled with Big Bang cosmology. We're not looking at a heat death, we're looking at the return of Jesus Christ.
Which is infinite, and this world is finite.
Yes,
there's a difference there.
Yes, but in the future life, the infinite God comes to man, right? So somehow there is an connection between the two.
Let me bring in other people who may want to. Who else would like to come in? Yes, Jutta Vandermeer.
So thank you very much, John, for a stimulating paper. My question is about what you said on methodological naturalism. You had a line on the screen there combining it with the notion that science is true, and then concluded that that entails metaphysical naturalism. Now, the notion that science is true is a very broad and complex kind of notion. There are many people who think that science perhaps is true about certain dimensions of reality, or perhaps that science has limitations in what it can know. And my question for you is, if you take those views of science, in other words, not science as an all-encompassing source of knowledge about everything, but as a more limited kind of endeavor, would you still conclude that methodological naturalism in combination with those conceptions of science lead to metaphysical naturalism?
Yeah, what I said was that methodological naturalism plus naturalistic inferences, assuming that the inferences based on methodological naturalism are true, becomes metaphysical naturalism, in the sense that you're ruling out supernatural intervention.
Okay, I guess then I understood you differently. I find that's only different.
Yeah, no, I'm not saying that it doesn't make science true, because I believe what you do in the lab, for example, the regularities that you find are still valid. It's just the extrapolations that you make from that into the future, for example, eschatology. If you're saying that that is true, the future picture of the Big Bang, then you've really come down on the side of metaphysical naturalism.
Okay, but then it depends on what you read into what science is doing. You read either the metaphysical naturalism into it, or
yeah, I'm looking at the extrapolation.
Right. Okay, I understand.
Yeah.
Thank you.
Steve Fuller.
Thanks very much. In a way, I want to continue a little bit down the road that Roger was taking you. Okay, so we've got this view here, your view, being that theology in some sense can correct science with regard to Big Bang cosmology. Does it go the other way around? In other words, is it possible that science can correct theology as well? Because I'm kind of trying to get a sense of what, because it's quite clear in your response to Roger that you want a kind of very reasonably tightly integrated view, it seems to me, of science and theology. That you take Pannenberg seriously, for example, right? That in some sense, right, that there's a sense in which theological knowledge claims have some bearing on science and can kind of veto them in some sense. And I'm wondering, does it also go the other way around?
It might. What I'm saying is that your presupposition, your worldview should be wide and broad enough to encompass both science and theology.
I appreciate that, but you've got you are including falsification. It seems to me, right? That one realm, that the claims from one realm can operate as a kind of a check, an epistemic check on the other. And I'm wondering, does it go both ways?
Yeah, I wouldn't say falsification.
Okay, that maybe is a little strong, but you have epistemic check going on.
You do have that because you start with a worldview and you interpret everything within that worldview, right? So I'm distinguishing between the observational data, the stuff that we actually see, the things that we actually do in a lab on the one hand, and models that are made to explain that on the other hand. And I'm saying that once you get to the role of models or theories, there is a worldview element in there. That whereas the first should be a check on everything that you do, you don't want to have a worldview that's counter to reality. But if it's being challenged by a model, then I don't think it's invalid to point out, well, what goes into that model, what kind of assumptions are behind it, what kind of a worldview does that reflect?
No, I understand that. I don't think you're quite answering the question. It seems to me that when we're talking about Pannenberg's quote, that Pannenberg is basically having, in your terms, one model checking another model. Unless you, or do you see that differently, what he's doing?
No, he comes up with a conclusion from theology and one from science. And he says, well, these can't both be true.
Right, but don't, in your terms, isn't that, those are two models that reach contradictory conclusions?
That's right.
Right, and you're actually allowing one to check the other, aren't you, or not?
Well, I'm saying that you have to look at the different levels of assertion that you have. If you look at theology, the basic level is biblical assertion, if you like, or religious experience. If religious experience or biblical assertion tells you that something about eschatology, that to me should trump any model that you have on science.
Well, why do you say that exactly?
Why do I say that?
Yeah, that's. I guess maybe that's my question. Why are you saying that? Why don't you say it goes both ways? Given that both are accountable to the same data. Right, both models are at the end of the day accountable to the same data, you said.
That's right.
So why don't the models check each other? Why is it a one-way thing? Are you bringing in an additional assumption here you haven't said?
I'm saying there's a difference between the data and the models that are built on the data.
I understand that.
So in science, we've got the observations, we've got the theories. In theology, we've got your religious experience, biblical assertions, and you've got theological models. So I'm saying the conflict is not up here.
Oh, so the relationship between the models and what they're models of is different in the two cases?
Yes.
I see.
I think we'll have to...
Okay, sorry, I just wanted to... Okay.
Sure.
Joey Chandler wants to come in at the back here. If you just pass it.
First, I'd like to thank you for a very excellent presentation. It's one of the best summaries I have ever listened to with regard to the relation between models and science. But I would like to add one footnote, if you would, or additional thought that you might want to consider. I think virtually all your models came from the physical sciences, and as such, they often involve some simplifying the situation. But I think there's a fundamentally different relationship between the chemical sciences and biology and life. And in this situation, the chemical models generate vastly more complex relationships in the real world. So they're not simplifications in the same sense. They're sources of complexity for the view of biology.
I agree with you that my examples are primarily from physics, astronomy, which is my background. But I also see a move in chemistry to reduce it more to physics, right? Is the trend there.
Explicit in pointing towards biology.
Yeah. But I do agree that it becomes very complicated there, as a previous speaker pointed out. Once you get to life, it's so complex. But there again, once you start extrapolating, there may be more than one model that can explain the data.